Alright guys, welcome to 2.1, Relations and Functions. We got two objectives to hit today. One is to analyze relations and functions. Two, to use equations of relations and functions. This is going to be a big review from Algebra 1 from about 2 years ago. We had about this exact same lesson. So here it is again. We're going to add a little bit to it, but not much. So let's review some key terminology here. So a relation in which each element of the domain is paired with exactly one element in the range is called a function, okay, where we have exactly one y value for every x value. The domain of the x values, the first number in the ordered pair. The range of the y values, the second number in the ordered pair. So really quick, guys, I just want to show you something. So I want to show you like a non-example of a function. Okay, so if we have 2 points, all right, so if I had the 2 points 1, 2, and then I have the point 1, 4. This is a non-example of a function. So this is not a function. Okay, this is not a function. The reason for that is if you were to graph this, okay, if we go over to 1, okay, you have to think of your x values as kind of like the input, right? It's the independent variable, so if it's like the input, if you think of this like a function, I think I taught in Algebra 1 as I taught it as a machine, right? So if you're putting x values into the machine, a function states that we just need something that is predictable. So if I put a 1 into the machine, every time I want to get the same thing out. And notice, if I put a 1 in here, I get a 2 out. If I put a 1 in here, I get a 4 out. So that is not the case. And then we talked about this thing, and we'll review this again today, where we have this vertical line test that this thing will fail. Okay, the vertical line test states that if I have a vertical line and it touches the 2 points, any 2 points on my graph, then I know that it is not a function. All right, so we'll get into some more of that. Here we go. Example 1. State the domain and range of each relation, then determine whether each relation is a function. If it is a function, we're going to actually skip this part of the directions. We're not gonna worry about the one-to-one or onto functions for now. We're just gonna state the domain and the range after we determine if it's a function. So if you're gonna determine this is a function, you might want to perform this vertical line test at each one of these points. And notice, boom, right here on this line, it hits 2 points, which is a big no-no with functions. So this is no, not a function, okay? But we still have domain and ranges. So for this, for 1a, let's state the domain and the range. So domain of the possible x values, we're going to assume this is going by ones. So this would be -1, -2, -3. So we have -3, -2, -1, 0. That is a 0, sorry. 1. 2, this is going to be, there's nothing at 2, so we're going to skip 2, 3, and 4. That's the domain. All right, and then the range is going to be the y values. Y values is going to start with this one right here, which is a -3. So we have -3, -2, nothing at -1, nothing at 0, but then we have one at 1. Actually, we have 2 at 1, but we only include one of them here. And then we have one at 2, and then nothing at 3, but then we have something at 4. Okay, so there's your domain and range. For 1b, they want you to state the domain and the range of this thing and determine whether this is a function. Okay, so if you're going to state the domain and range, it's kind of silly that we would state it again here. This is the domain, this is the range, right? So for each element of the domain, we have, since the domain is never repeated here, you guys, this is a big trick. Look, all these x values are different, right? They're all different. -3, -2, -1, 0, 1. Okay, so since they're all different, we don't really care what range values they go to. This is going to be a function. So yes, this is a function because for every x value, we only have one y value. Okay, even though that 1 is going to 6 here and -1 is also going to 6, let me show you what that looks like. If I said 1, 6, I'm up here. If I'm at -1, 6, I'm over here. That still is okay because it passes the vertical line test. Okay, so don't be confused there. A discrete relation, so if it's a discrete relation, you have to lift your pencil in order to draw it. So, you know, these things where we have, like, you know, graphs that look like this, and this is the whole graph, right? Nothing's connected. It's just these points. If I have something that looks like that, that relation is called discrete because you have to lift your pencil in order to draw it. Continuous, though, however, you can draw without lifting your pencil. So looking at like a line, for instance, I can draw a line without lifting my pencil. I can draw a parabola. You know, anything that, there's so many examples that we could give. Like whatever you can draw without lifting your pencil. You can do something like this. Anyway, these are all continuous, so there's no gaps. Okay, then the vertical line test is something that I already talked about. It's used to determine if something is a function. And again, you're just drawing vertical lines and seeing if it crosses a graph in more than one place. So notice this particular function here, sorry, I just said function. This particular relation is not a function because the vertical line test shows that there are two y values for the same x value, whatever that x value is right there. Okay, so example 2. The number of employees a company had in each year from 2004 to 2009 were, they give you all the numbers. Graph this information to determine whether the relation is discrete or continuous. Does the graph represent a function? Okay, so in 2004, so 2004 we had 25 employees, somewhere up there. 2005 we had 28. 2006 we had 34. Okay, 2007 we had 31. Somewhere in there. 2008 we had 27. Somewhere in there. And then 2009 we had 29. Something like that. Okay, so it says here that we're supposed to determine, is this relation discrete or is it continuous? Okay, so for this one, we could say, you know, if you connected those dots for some reason, you could say that this is continuous. But in order to graph this, in order to put those points on the coordinate plane, we had to lift our pencil to get the various plots, right? So we're going to call this a discrete function because we're doing individual points, so it's discrete. Okay, it does represent a function, yes, because it passes the vertical line test. Okay, so that's example 2. Example 3 says graph this guy and determine the domain and the range. Then determine whether the equation is a function, state whether it is discrete or continuous. Okay, so you guys, feel free, I mean, throw that into Desmos if you want to check your answers and stuff and see how this works, this function. But you can also just make one of these XY tables as always. I like to start with 0, go into the negative a little bit, go into the positive a little bit, and just see what happens. So if I plug a negative 2 in here, negative 2 squared is 4. 4 plus 1 is 5. If I plug a negative 1 in, I get 1 plus 1, which is 2. Plug a 0 in, I get 1. Plug a 1 in, I get 2. Plug a 2 in, I get 5. So if I go to plot those points, negative 2, 5 is here. Negative 1, 2 is here. 0, 1 is here. 1, 2 is there. And 2, 5 is there. I have a parabola. And notice it is a parabola. It's actually the x squared parent function parabola that has moved up 1, right? So the y-intercept is now at 1 instead of at 0. Okay, so is this a function? Yes, it passes the vertical line test. Is it discrete or continuous? I'm going to say that this is a continuous function, right? This is continuous. Yes, we had to lift our pencil to draw these points, but we're graphing the image x squared plus 1, which is this actual solid line. So this is going to be a continuous function. We do not have to lift our pencil in order to draw it. Okay, moving on. Independent variable. It's the x value that makes up a domain is an independent variable. Remember that, you know, whenever we're making an xy table, you guys, we get to choose this guy right here. right? That's the reason that we get to choose x is because x is independent. All right, so x is independent, but the thing that is dependent on that is the y value, right? So y values depend on x. So the dependent, another name for that is the y values. So make sure you get that in your notes if you don't remember that. And then function notation. Yes, believe it or not, we did do this in Algebra 1 as well, very beginning of the year. I started throwing this at you guys where I replaced the y with f of x, right? That becomes increasingly important as math progresses. So this says, suppose you want to define the value in the range that corresponds with 2 in the domain. So the value of f of 2 can be found by plugging a 2 in for every x in the equation. So yes, we did some of these where, you know, if it's in function notation and it asks you to find f of 2, we can say f of 2 for this particular case is equal to 2 times 2 plus 1. We just plugged the 2 in for the x in the equation. So we know that f of 2 is then equal to 4 plus 1, which is 5. Okay, so for example 4, they want you to do a little bit of that. It says, here's the g function, right? G of x is equal to this. Okay, let's find g of 2.8. So all they want us to do is plug 2.8 in. So we have 0.5. I always use parentheses, you guys. Make sure you guys get used to that. 2.8 squared minus 5 times 2.8 plus 3.5. Okay, so when you go to solve this, make sure that you start with your parentheses. You're going to start right here. You're going to start with 2.8 squared. Okay, so I guess I can solve this for you guys. I was going to just let you guys do this, but I'll do it so you can check your answers here. So 2.8 squared gives you 7.84. Okay, then you're going to multiply that by a half. So 7.84 times 0.5, and then that's going to give you 3.92. Okay, then we're going to subtract 5 times 2.8. 5 times 2.8 is 14. And then we're going to add 3.5. Okay, so when I do this, I get 3.92 minus 14 plus 3.5, which is, I'm getting negative 6.58. Okay, then they want us to do 4b, where you plug in, instead of a number here, we're plugging in a term for a. Okay, so it's going to be, the answer is going to be in terms of a, right? So we're just going to plug in a 4a for x. So we have 0.5 times 4a squared minus 5 times 4a plus 3.5. Okay, so if you square 4a, remember that you have to square both things there. So 4 squared is actually 16, so this is 16a squared when you take it out of parentheses. Okay, we're going to multiply that by 0.5. Then we're going to subtract 20a and add 3.5. When I do this, 0.5 times 16 is just 8. So we have 8a squared minus 20a plus 3.5. All right, so that's the answer because we can't simplify it any further. I guess that's it, guys. So the last thing is, please don't worry about the onto versus one-to-one functions. Skip that part of the directions. You guys have homework sheets, and I'll see you guys in class.